Hi everybody, I'm sorry I can be with you today. We're going to be going through the notes for lesson 2.1. It may take you most of the period to copy these notes down with me and kind of walk through stuff. That's okay because you have all of tomorrow to finish up your homework assignment during class. So the main goal is don't have homework to take home with you over your long weekend. Okay, let's kind of walk through stuff together. First of all, we do have some vocabulary. And by the way, this should all be review kind of concepts. We have vertex, we have parabola, quadratic function, vertex form of the quadratic function. So today our focus is going to be on taking a closer look and reviewing the quadratic equation, and then looking at graphs. That's going to be our main target today. So the first thing I want to do is direct your attention to this image that's right here, looking at this pattern. And I would like you to take just a moment to see what kind of a pattern you see forming. Okay, hopefully everybody in here is thinking that it is 1 squared and 2 squared and 3 squared and 4 squared. So if I was just looking at area alone and they asked me to write the function, it would of course be f of x equals x squared. But over here it says, assume that the areas in the table are doubled. So doubled means multiplied by 2. So that means that our function should be 2x squared. Again, it's not this pattern. It's because it says consider a function where the areas are doubled. These are just the areas. So hopefully that's okay for you. Now, I'm not going to spend any time on the graphing. We're just going to kind of slide on down here. By the way, I just want to remind you, anytime you need to, pause, and you can take more time to write. Okay, a function is a quadratic function if it can be written in the form f of x equals ax squared plus bx plus c, where a is not equal to 0. Now, if a were 0, we'd be back to a linear function. So you have to have at least one x squared or squared variable in the problem. Now, the parent function for all the functions we're going to be looking at today is this little beauty right over here to your right. You'll notice that our vertex is right there at 0, 0. And that also happens to be our y-intercept. The graph that is over here is also sometimes called a parabola. So you'll have people call it a quadratic and a parabola. Kind of goes back and forth. Now, our main focus today is vertex form. Now, this is the form where we have f of x equals, there's usually some sort of a multiplier out in front of your parentheses. That's a. It also might not be there. We'll see some cases with that. Minus, that's super important, h plus k. Now, you'll notice that says minus, but yet when we actually write the vertex, it's going to be h comma k, not negative h comma k. That's a minus h, not a plus a negative. So that's the vertex of the parabola. Vertex form is useful because it helps you find the vertex and get your graph done more quickly. Okay, before we start doing some graphs, let's just talk a little bit about transformations. So what you see right up here is the most general form of the equation with no numbers in it. And now we're going to slide on down and we're going to look at what happens when we start putting some numbers into place. Now, I always like to start by finding what kind of a transformation has been done left or right. This is my h. My x is the x coordinate of the vertex. I'm reminded of that because it's next to the x. And x changes are always opposite of what you see, and they go horizontally left or right. Over here we have the k. The k is going to be our vertical changes. So let's write this down. So these are horizontal changes. And that is a vertical change. as I often say to my students, the x is the opposite of what you see because it's in the parentheses. So that's going to end up making it go the opposite way, but the k is not in parentheses. So therefore, it will be exactly what you see. Now the a out front, this little guy right here causes two different things to happen. So if a is a negative, it's going to cause a reflection. Across the x-axis. Now if a is, so if it's between 0 and 1, I want you to think decimal, I want you to think fractional values. That's going to cause a vertical compression. So I'll just write vertical compress. If your x value, your a value happens to be larger, let me put an a there. So if a happens to be greater than 1, it's going to cause a vertical stretch. Okay, so let's take a look at some examples of what's going on here. So first thing I'm going to want to do is I'm going to look at inside my parentheses. So that 2 that is right there is going to cause my graph to go the opposite of what I think it is. So it's not going right 2, it's going left 2. Now this has two elements to it. It has the negative, so we have a reflection. And I'm not going to write across the x-axis because that's really the only type of reflections we deal with. Yes, there's a way to do y-axis reflections. We just don't do it. And the 1/2 causes a vertical compression. Okay, let's take a look at another one. See if we can kind of firm up these ideas for you. Okay, so that -1 makes it go right 1. The -3 makes it go, sorry about that, guys. I'm still a little sick. Makes it go down 3. And the 2 that's up front is going to cause a vertical stretch. So hopefully that made a little sense. Let's take a look at another one. Okay, so again, I always like to start with the horizontal and vertical changes, and then I talk about stretches or compressions. Remember, it goes opposite of what you see, so it's going to go right 3. Now let's talk about this. So in order to figure out what's going on, first of all, I automatically know it's between 0 and 1, which is going to cause a compression. But if you're not seeing that, let's turn it into a fraction. So as you can see, that is between 0 and 1. That's going to cause a vertical compression. And by the way, if you're not sure what I mean by compression, that's like if I were to pick any person in the class right now and I were to keep them with the exact same mass and I just squish them, they would get wider. Okay, that causes a vertical compression. All right, our last one. Again, that's going to go right. It's always the opposite of what I see, right 1, as opposed to my up and down. That's going to go up 2. And then finally, we've got our vertical stretch. And again, it is a stretch because the a value that's in front of the parenthesis is greater than 1. Okay. So let's talk about some key features of a graph. Okay, so first thing I want to note to you is your vertex. So your vertex is right down here at the bottom. And your vertex, it looks like it's a 3, 4. Now, I also want to point out to you 3, 4. There's my vertex. Now, your axis of symmetry, and I'm going to write AOS for that. That's always equal to the x coordinate of the vertex. So when you write it out, I'm sorry I put the equal sign there. That's not a good way to write that. You should write x equals 3. Now we also need to talk about minimum or maximum. Minimums are the lowest points on the graph, and maximums are the highest points. Quadratics have one or the other, but not both. As you can see from looking at the graph to the right, we have a lowest point, not a highest point. Lowest points are like valleys, highest points are like tops of hills. So we have a minimum. And from here on out, I'll just write min. And that minimum is going to be the vertex. So I got all of that information just from the vertex. So vertex, axis of symmetry, and minimum or maximum all go together. Now let's talk domain and range. Since we're doing a quadratic, the domain on it, so let me just kind of backpedal just there a little bit. So a domain is the group of values over which the function can be evaluated. It doesn't matter which value of x, remembering domains are x values, I substitute into my problem, I will be able to find a y value. So that means I go from negative infinity to positive infinity. Both of those will have a parenthesis on them because infinity is not a specific value. Next, I have range. So my range of my function is going to be my values over which I can have y's. In this particular case, the lowest y value I can have is that one that is right there, and it is 4. But my graph continues on upwards with arrows, so it's infinity. Now, of course, infinity gets a parenthesis, but my graph can actually be equal to 4, so I will have a bracket. Now, before I move onward, I want to point out to you that these are a series of values where the lowest is on the left and the highest is on the right. So make sure when you're talking about your infinity that you get the order correct. 4 is definitely lower than infinity. So those are my key characteristics. Let's try it again on the next equation down. Okay, first thing I'm going to do is find my vertex. Now this time I don't have a graph, but remember, I don't really need it. Your vertex is the opposite of what you see in the parentheses, and the same as what you see on the outside. My axis of symmetry is always x equals the x coordinate of the vertex. And in this case, it's got a graph right here where there's a negative in the front. That means it turns downward. So even without graphing it, I know that I'm going to have a maximum at my vertex. This is the maximum value of x. That's the maximum value of y. Now let's talk domain and range. Now your domain will always be the same on these because you can use any value of x, so negative infinity to positive infinity. Now your range, on the other hand, is going to depend on your graph. Now since my graph has a shape like this, I will go from negative infinity to whatever this highest y value is, which is that vertex point. Notice that this time, I'm putting the infinity first because it's negative infinity, And then I'm going to -5, and I'm going to put a bracket on that because my graph can actually equal -5. Notice the difference between the two. This one, the graph had a minimum, so I go from the minimum upwards. This one has a maximum, so I go from -infinity upwards until I get to -5. Hopefully that is okay for you. All right, so hopefully you're liking more algebra and a little bit less statistics, hopefully. If not, ooh, well, you know, I guess it could be worse. Could be worse. Give you a pause right here to flip over to the other side. Oh, I got sideways. All right, let's do some algebra. So now we're going to take the information we have and we're going to write an equation. So just to point out to you real quickly, the y-intercept is written as 0, -1 as a coordinate. Now we're going to take our general equation, which is this one from the previous page. So there's my equation, and I'm going to fill it in. So the first thing I'm going to do is I'm going to put in my vertex. So substitute your vertex into the problem. In this particular case, there's my vertex. This is my H, and that is my K. So I'm going to put them into my problem. Now you'll notice that turn from a negative to a plus. That's because of the minus negative turns to a plus. Now I need to know what A is. So I'm going to take my y-intercept points as my x and my y. And now I'm going to use some algebra to solve this. 2 squared is 4 plus 3. I'm going to subtract the 3 to the other side. And then I'm going to divide. So now when I go to write my equation, oh, I've kind of like doubled up here. Sorry about that. This part should be down here. Sorry about that. Sorry. Now when I go to write my equation, which is right down here, I'm going to have y equals, first thing I'm going to put is my negative a, so that'll just be -1. I don't have to write the 1 though. Then I'm going to have x plus 2 squared and plus 3. And that's my vertex form of my equation. Let's do one more together just to make sure you got it. And then we'll do a little bit of a word problem. Just kind of to make that all nicely done. Make sure everything looks really good. Okay, so next thing I want to do, I'm going to do the same process that I just went through, but I'm going to kind of squeeze it all together rather than 3 steps. Okay, here's my vertex. So that's H and that's K. So let's put it into the equation. So that's just going to be x minus 1 squared minus 4. Now, unfortunately, I don't know what A is, but it's okay. I've got this point. I'll put it in for x and y. Okay, so I've got -1 equals A times -2 minus 1 squared minus 4. So it's -1 equals -3 squared is 9A minus 4. Move your 4 to the other side. 3 equals 9A. Divide both sides by 9. So that's 3 over 9, which is 1/3. All right, let's write our equation. Y equals, and you're going to put your A value. Then you're just going to put in the H and the K. Notice I'm not putting in the X and the Y this time. And that is your answer. So hopefully that went really well for you. Okay, let's slide on down to problem 4 using all the same stuff that we've been doing and a graph. So we have the height of a hit ball is a quadratic function, which you can see in the graph. The ball is hit with an initial height of 4 feet, which makes sense because someone's going to hit it, so they're at least 4 feet tall. It reaches a vertex at 20. What is my equation? Now, this is a little bit new here. We're going to write this into standard form after we're done writing it in vertex form. So first thing I'm going to do is I'm going to go over my graph, and I'm going to find my y-intercept. So that is at 0, 4. So that's just going to work just like problem 1 did up here, where they gave me, look at that, there's a y-intercept. Same information. I also need my vertex. So that is over here at 1 second and 20 feet. This is going to be my h, and this is going to be my k. So let's go write our equation. So first thing I'm going to do is I'm going to write y equals a times x minus 1 squared plus 20. Now, I don't know what a is, but it's okay. I can find out using my y-intercept. Please put this in for your x and your y. Okay, I'm moving that 20 to the other side. Now, when you square that -1, it becomes a +1, so my a is just -16. Let's write our equation. So here is my equation in vertex form. Now, you may be saying, but how am I going to get rid of those parentheses? Now, I want to remind you that this is x minus 1 times x minus 1, and you're going to need to FOIL that out. So y equals -16, and I'm going to give you just a moment to FOIL it out. Okay, hopefully you have it all FOILed by now. It's x squared minus 2x plus 1. Now you're going to distribute your -16 to everything on the inside. And then we just need to simplify our problem and we will be all done. So this is called standard form. So that's what standard form looks like. That's vertex form, the one with the parentheses, that's standard form. And you'll notice in this case, it said to write it in y equals ax squared plus bx plus c. Notice no parentheses. So that's why we don't have any parentheses on that. And again, if you need another moment or two, please pause it here so that you can feel like you're caught up. Okay, we're coming into the home stretch on our problems. We have one more of these, and then we have one more example. Okay, so looking over at your problem, that's my h, that's my k. Oh, nope. That's my x, that's my y, that's my h, that's my k. Much better. So just like we did last time, we're going to start by filling in our equation into vertex form. So I have y equals a times x minus 2 squared plus 10. Just like last time, we don't know what a is, so this is where we're going to use our intercept. Clean it up a little bit in terms of your parentheses before you start moving anything from side to side. That's called simplifying. I got that 4 by taking -2 and squaring it. Move the 10 to the other side. And divide both sides by 4. Now, 4 and 6 both have a common factor, which is 2. So I'm just going to go ahead and reduce that. Now I'm going to write my equation so that it's in vertex form. That's vertex form. How do you know it's vertex form? Because if I ask you for the vertex, you would be able to look at it and see. Also, it has parentheses. Now let's work on getting this all into standard form. So first thing I'm going to do is I'm going to foil this part together. If you need to pause it for just a moment while you foil it, please do so. I'm now going to distribute my -3/2 and reduce any fractions. So hopefully that came out okay for you. Let me pause here and take a sip of water so hopefully I won't cough through the next example. Okay, so we use the word parent function. Now, if you remember a while back when we were starting our notes out, I talked to you about the parent function very briefly, and I reminded you that the parent function of any quadratic is f of x equals x squared. Okay, that's just the basic quadratic right there. Now we are going to take that quadratic, and the only thing we're going to do to it is move it left 1 and up 3 units. So that means that my new function, notice I didn't say anything about a vertical stretch or compression. I'm just moving it. That's all I'm doing. So I'm going left 3. So that's a horizontal change. Left is typically -1. And I'm going up 3, so plus 3. So you'll notice when this simplifies, it's x plus 1 squared plus 3. And that is my new function. So hopefully that feels okay to everyone. No issues with that. Okay, let's take our parent function and move it again. So just a reminder, here's your parent. Okay, we're going to be going 2 units to the right and 5 units down. Notice it doesn't say anything about any reflections or vertical stretches or compressions. Okay, so right 2. Opposite of what I see, so it would be -2. And then down 5 would be -5. And that is my new graph. So no issues with that. Oh, hang on. It says put it into this form. So let's practice that. So you would write this parenthesis twice and foil it. If you need to pause it so you can do that, please pause it right now. I'm just going to barrel ahead. And that is what my function looks like in standard form. Vertex, standard. Okay, let's do one more of these to finish off our notes. Let's see here. This time we want j of x to be a function who's going to reflect. But remember, our only reflections cross the x-axis. We don't do y-axis. And then we're going to translate down 1 unit. Okay, so here's my parent. So let's make it j of x. Now this does say it has a reflection, so that means my a has to be negative. So negative x, we're translating down 1, so we're not going to go anywhere horizontally or vertically. And down 1, so all cleaned up, that's negative x squared minus 1. And because we happen to have a 0 on that side, we also happen to also be in standard form. So once we simplified it out, it just happened to, we didn't have to FOIL anything. We just got our answer. So hopefully that's okay with everyone and you have no issues. Now, this should have taken you most of the class to get through because my time is 30 minutes going straight through. It's okay with me if you put off doing your homework till tomorrow. That's perfectly fine. Although personally, I would go ahead and start working on it and then finish it up tomorrow in class. The last thing you want to do is drag this into next week because you know as well as I know that there is no way on Wednesday night you're going to sit down and do this homework. So you might as well start working on it now. Your homework is in Savas. You make sure you go in through ClassLink if possible. If you're not able to go in through ClassLink and Canvas, then goes to Savas directly, but always start with going in through ClassLink. And I hope that you both, all of you, have a wonderful day.